A lot of people hate these because the stories are long and very few people actually learn statistics, I feel, before they take the SAT. Like, I don't think I ever did. So there's just like foreign topics, especially this one, where we're really being tested in this concept of margin of error. So let me try to explain what's going on and define this question. I'm going to say the strategy here is just to memorize formulas, though it's kind of like more like memorize vocab. We really just know what this means. So polling agency wanted to test whether a ballot measure would pass with greater than 50% yes votes. It's just setting it up, right? Obviously, if you have more than 50% of the votes, you win. The agency sampled 1,000 registered voters selected at random, so that's all good. A lot of people were selecting at random, so there's no bias threat here. And 50.6% of the voters favored the ballot measure. So according to this, that thing is going to pass. But the margin of error associated with the poll was plus or minus 3%. This is really important. Based on the poll's results, which the following statements must be true. So before we even look at the answer choices, let me explain what that plus or minus 3% means. It means that if we take that 50.6%, we've done this some math behind the scenes to determine that our 50.6% isn't perfectly accurate. It's probably a good estimate, but margin of error says we could be wrong. We think we're off by maybe at most 3%. We could be off by more, but there's a statistical reason that we come to this plus or minus 3%. It basically means like we have a high confidence that whatever the result is, it's going to be within this range. So it's not 100% confidence, but it's pretty darn high. Okay, but we need to understand what that range is, right? So if we were off by 3% in one direction, it's possible that we would have a winning vote of 53.6%, right? So maybe you win by even more because we were wrong in that direction. But we could also be wrong in the opposite direction of minus 3%. And so that means that we're going to have 47.6%. And that's no longer winning. Right? So if we're accurate, we win. If our survey was perfectly accurate from the start, we win. If it was off in one direction, we win by a lot, even more. But if it's off in the other direction, we lose. So this is a problem. It means we actually don't know what's going to happen. We think the odds are a little bit in favor of this ballot measure passing. But it's still statistically like not unlikely that it could fail by just normal statistics. So what does this mean for our answer choices? Well, let's look at them each. Choice A, the percentage of voters who will vote yes for the ballot measure is 50.6. No. Even if they didn't bring in margin of error at all, this is not true, right? Every survey is going to ask a smaller sample of the population than is actually trying to be measured. So we have a survey that could be really close, but it's not a must-be-true situation ever that our survey is going to be perfectly accurate with what actually happens. There's always room for error. It's just about the way that surveys work. We're not asking everybody. Until you ask everybody, you don't know. Choice B. The ballot measure will pass with more yes votes than no votes, but the percentage of votes it will receive cannot be predicted. Well, I agree with the second part. The percentage of votes it will receive cannot be predicted. We can come up with estimates for the percentage, but as we saw with this margin of error thing, we don't actually know it's going to pass. We don't know if there will be more yes votes because it's possible within our margin of error that the no's win, that the yes is only going to be 47.6%. That's a reasonable thing to happen, so this is no longer true. C, the ballot measure will pass with at least 53.6% of the vote. This is just completely misinterpreting what margin of error is. This is just not even possible. Like, it could. It's still a slight possibility according to how margin of error is calculated and what it means, but it's not likely. D, the poll's results do not provide sufficient evidence to conclude that the ballot measure will pass. This is definitely the answer because like we saw, if we go 3% in one direction, we're good. 3% in another direction changes the outcome. So we really don't know what's going to happen. This happens all the time in like real elections. We get a poll that says one guy is winning, but people forget about that margin of error, and then on election night, they're surprised. So we always have to keep in mind polls, surveys, they're not perfectly accurate. They are a guess at what is happening. They are scientifically backed, some better than others, but there's always this room for error, and this is what this question is trying to test you on, is it is a good guess for what is happening, but even that good guess has some variability and some possibility that we'll be surprised about what actually happens.